In my previous video I mentioned that I'm a big fan of non-conventional controllers and motion controls in particular. That whole video was about an immersive FPS mouse to which I added the ability to select, draw and holster weapons just by using hand movements. Using the same tech I wanted to finally build something that has been on my backlog for quite a while. A body tracking controller that detects real jumps and ducks. You see, I really love movement. I've been doing parkour, rock climbing, and I always admired advanced movement mechanics in 3D games. But even the most sophisticated tech, like VR, which immerses you completely in a virtual world, still fails to provide convincing vertical movement. So the goal of this project is to build a device that will accurately detect jumps and ducks and test it in my favorite movement-focused games. The hardware itself is pretty basic, an ESP32, an MPU 6050 gyroscope and a DC-DC buck converter, so I can run everything off a single 18650 battery. I chose the ESP32 because it can act as a Bluetooth HID device natively. I need to mention that the first prototype used an Arduino Leonardo connected with a cable. It worked, but the cable was quite annoying. Now, I know the current build looks a bit rough. I tried to 3D print a proper case, but I got very unlucky with the resin this time. It was incredibly brittle. Every prototype cracked apart. After multiple attempts, I gave up and just built a case from what I had available. Most of the work on this project went into analyzing the MPU 6050 data and designing an algorithm that can reliably detect jumps and ducks. The first major issue, the start of a jump looks almost identical to the start of a duck, because when you jump, you first squat and accelerate downward. Same for ducking, downward acceleration. My solution? Use different signals for the two actions. For jumps, I detect a strong upward acceleration spike. For duck, I detect torso tilt. Then came the double jump problem. When you land, your body decelerates upward due to the floor stopping you, and this can look like another jump. So how do we distinguish it from the intentional double jump? For a real second jump, you smoothly go from landing into loading the next jump, which makes the acceleration spike wider. There are more details, of course, but I don't want to turn this into a full technical deep dive. If you are interested, the code is available on the project's GitHub, link in the description. Now for the fun part, testing. This is the setup I'm using. The crucial part is a flat screen TV positioned roughly at eye level. If you stand close enough and the screen fills enough of your field of view, you can achieve a surprisingly high level of immersion. For other controls I'm using Joy-Cons. They allow much more freedom of movement than a standard controller. I tested the jump controller in 3 games: Mirror's Edge, Hot Lava and Mirror's Edge Catalyst. And spoiler, the controller performs really well. I beat the first Mirror's Edge using it, completed several worlds in Hot Lava, and I'm currently progressing through Mirror's Edge Catalyst.
Moving to the roofs ahead. Looks like you're gonna have a fight on your hands.
Overall, I am very pleased with how accurately this controller recognizes my movements, and the whole experience of using it is great. You just wear it, turn it on, and it works. Also, I measured how much calories do I burn playing with jump controller. On average, it is about 7 calories per minute, which is 58% of calories expenditure during running. That's all for now. Thank you for watching and have a great day.